pickle. So what is pickle? Pickle is an object which the model, which the .py file store in object format. So why we store it? While we create a front end, the moment when user enter the experience in the backend, it has to call or not. Guys, you getting my point? So it never calls all the 20 lines. So enter experience, it call the object to generate predictions using which equations? Y equal to mx plus c, using SLR, simple linear regression algorithms. Are you clear or not? Okay, so pickle we done, and just go here and then machine learning. In this machine learning regressions, and I have here, okay, so not this one. We also introduce sklearn.matrix, mean squared error. You never get R square, guys. So you can also write sklearn.matrix, mean squared error. So sklearn, how to import mean squared error? From sklearn.matrices. Okay. Now let's open the file. Today we'll finish simple linear regressions. Okay. Today we'll complete simple linear regressions. I'll give you some project to home, and then tomorrow, once everybody get in, we'll work Google Generative AI. Clear? So now, once you open the file, let's see whatever the code we had earlier yesterday, whether now you guys expert, whether you can work on VS Code, whether you can work on Spider. But today, what is today's date, guys? 10th. Today's date is 10th. And here, pickle, streamlit, model performance, model evolutions. We have all those things. And we learn how to explore the model in VS Code. All right. And we completed the front end and back end and deployment. We learned this is what we did this case. Okay. 42, 43. Okay. Now what I want you to do. So I'll tell you, you can also work in Spider, but today, see, there's a two reason I switch. VS Code, you can know. I want you to introduce statistics in this file, in the VS Code. So let's go here and copy, then paste here. Okay, minimize. 1 second, I'll open the file. $730. Okay. Bias variance I'll explain today. Doc. Okay. With statistics. See this one. We done this one. Everything part completed, guys. Xtrain, Xtest. We build the model. We predict with Xtest. And Xtest, I hope we already done this. We predict the future or not? How to predict the futures we done. Now, can you try this one? From sklearn.matrix, import R squared mean squared error. So what is performance measures of regressions? R square adjusted R squared. Yesterday we built the model and we didn't check the model is accurate or not. So how to check? Go to the Spider. Let's copy the code, and in the spider, you already done that, but still, you just go here and execute that. 1 second. Once you're done, type this. In the end of the code, please add import r squared and mean square error. Just go ahead and execute. Online team, offline team, please do so. And I want you to work in Spider to has more understand about this, guys. Can we continue, online team? Yeah. Oh, okay. No problem. Okay, Pratish. So what is the from sklearn.metrics import? Sir, how to create the model all in one for different sector like IT? See, Sashikumar, sector is different, attribute is different, algorithm is same. Understand? So you need some experience for that. You get to know day by day when we complete all this one model. So we get to know. See, you need to add more data sets. You need to add more attributes. Okay. Now, are you import this, guys? Now, create r squared is equals to r square equals to, write this code. You already done that before, just leave it. Now I want you to check this. Statistics we learned in prior classes, guys. I want to add all the statistical concepts in the code which we developed. And today I'll full stop to simple linear regressions model. Yesterday, I hope everyone completed or not the deployment part. But I just want a few concepts in simple linear. What is bias? What is variance? What is training accuracy? What is testing accuracy? What is model accuracy? I want to introduce all these things, guys. So that's why please work. The one who absent, you never understand the class. I want you to go and attend the recording. And I would request do not miss any session hereafter. Done this, guys. Now create R square. R square, you always compare between y test and y pred. Y test mean actual table, y pred is predicted table. Guys, are you getting my point? Classification also. Accuracy always compare on y test and y pred. Mean squared error also y test and y pred. RMSC. Just go here and can you check what is the R square range? MSC. You get this one. Let me know. Accuracy score not required because it is a regressions. Online team, are you working with me, guys? Online team, are you working? Everyone. Very simple. Today, I'm telling the team to open Spider because in VS Code, it's a little hard because that's for deployment we can use. But for understand each and everything, how the work, yesterday I implement R square, but most of them not understand. I can know that. So that's why you can work this one and write this first R square. What should I get the range, guys? R square, MSC, root mean square. So just here. So R square, are you got 1, 0.9 and all those things, guys? Check this. Are you done this one? No? Please quick. Online team, I don't know. Are you guys working, team? Are you guys working? Yes. Yes. Typing. Please type this. We split the data into four parts: X train, Y train, X test, Y test. We build the model using, yeah. Okay, Srikant, no problem. So Srikant, what we done, guys? So team, the students who joined, what I try to say, just open your spider code. Whatever code we done in VS, copy that and paste it today. I'm implementing statistical learning introduced in simple linear regressions. So that today will last days of simple linear. I'll wind up these algorithms. Tomorrow we go for generative AI. Then we go for multiple linear regression algorithms. Okay. Okay. Guys, it's done now. So completed, guys, this part. Okay, done. Very good. So how much you got this one accuracy? I mean, this part, guys. Just go here, Y test, and I think I have to make it as Y red. Okay, just go and check this. Are you got all this value? So what is R squared? 0.9. A good model or not? It is a good model or not, guys? See, once you find out 0.98, no need to go to the next part. So this one we completed. So here in the same code, can you write? So this is called Y test value, Y predictions we want. So this one is not required. Coefficients, we know this. Okay. X train, we don't want it. So regressions, LR, column names, you already know these equations. We don't go for it. Okay. Now from sklearn variance threshold variance value, we want to drop the feature based on threshold. See, can you try this? What is threshold limit? Actually, this is not required, but still, I want to introduce to know the variance threshold value. We want to drop the feature based threshold, but do one thing, 35, you don't want it at this moment, you can ignore. Okay. And the little, just scroll down and I have here. Okay. This is also, we don't want it. VT variance, we don't want it. I will share this. This is also not required. Okay, so this is also not required. Now, 2 minutes, variance threshold. Okay, you get variance not required, this one as well. Just wait. Okay, guys, I want to use this. Listen to me. So today I want to introduce OLS model. Guys, listen to me. Don't talk. Startsmodel.api. Let me introduce very important concept. Is called startsmodel.api. You know what is API? API is applications program interface. You know what is agent does? Brokers, they take commission from one agent, they take commission from another agent's, guys, right? It's a broker. So API is take statistic formula. So before that, I want to show you some of the API. Just go here and try this now. Startsmodels.api. Okay. I want you to refer this model. The reason why I'm showing this, guys, please listen and then do it. So here, do you know you some of them learn MSc statistics, BSc statistics or not? Sir, I'm getting error. Y prediction is. Can you, Raman? That is Y pred, buddy. It's not Y predictions. You define Y pred and you mentioning Y prediction. Come on. So regressions plus imputations, generalized estimating equations, discrete count models, multivariate models. This is all statistical theory part. You guys getting my point? So we don't want theory. So we need the concept relevant toward machine learning. So in here, regressions, we use OLS or not? What is OLS? Ordinary least square, guys. This API, I try to plug in here. Can you please do this? From starts model dot API, I'll give more explanations of this model on multiple linear regressions. Now just go here. I'm sorry. From starts model dot API, import OLS, Y train, X train, or maybe X train, Y train, dot fit summary, dot fit summary. Is sample because the data set is sample. So here, p value, what is p value I got? Do you see the model generate some value? Model generate 0. So that means it is a good model. Guys, are you getting my point? So here, if you see this skewness, curtoise, so R square is computed without, since the model is best model. Okay. So guys, I hope you're clear what is meant by OLS. Now in upcoming class, whenever we build multiple linear regressions, can I get multiple variables or not? X1, X2, X3, X4. Guys, are you getting my point? Online team. So just go here and now. So this is regression table code. This is regression table code and we introduce two OLS and starts.apis. OLS and no. See, you don't consider this negative skew. It's just a number. Skew negative, that doesn't mean that it's a negative. Until you see the visual representations, you can't find out. You check these values, guys. Are you clear? But in the regressions table, you can get this. Okay, Venu. Guys, are you done this now? Now, can we go to the code here? Just go to the PDF part. Import pickle. Are we pickle it? Now load the pickle and just go here. That's it. So that means today we complete statistics analysis, all those things we done, guys. Just one moment. Salary data. Okay. So this part we completed. But before extrain and means and dimensions, I will share this PDF. You can refer to that. So statistical part we done, R square we understand, adjusted R square we understand, OLS we understand, regression table understand, ANOVA framework understand. That means theory, practical, both matched. Guys, are we clear? The code also understand. One thing I introduced today, the main concepts, bias, variance. The next concept is bias and variance. But before, I want to introduce what is overfitting, guys. What is overfitting? Train the model with more attribute. What is underfitting? Okay. It's saying train the model, not test the model. Am I correct, guys? Train the model with less attributes. I want to explain the two things, guys. Minimize. And once I complete this explanation, then I want to add two line of code. After that, we complete simple linear regressions model. Clear? Minimize. Okay. Then see this, guys. The one bias. Bias means what? One side. You know, guys. Anyway, let's have a look at this. In the data set, listen to this. Please understand what I'm speaking. Any questions, ask me. In the data set, we split the data with train and test, isn't it? Let's assume training data points are blue point. Training data points are blue point. Testing data points are I'm sorry, the red points are test data. How we build the model? Train the model or test the model? So when we train the model, are we connect the data with the training points or not? Answer me yes or no. Because we train the model, we don't test the model. So when we train the model, let me tell you, training always refers to bias. Training point you considered as, testing point you considered as variance. Are you clear, guys? Training point considered as bias, testing point considered as variance. When I build the model with the training point, we are very far to the testing point or not? Guys, are you see this? We are very far to the, this concepts we called, can I write low bias and high variance? Can I write this? How many of them understand, guys? Raise your hands. Very less. I understand. The guys who understand it will be very fantastic. See, yes. Srikant, guys, online team, are you clear or not? Got it. Got it. 50%. Let me explain this one. Let me one more time. See, guys, when I teach something, machine learning is not a code. Machine learning is a concept. Machine learning is a math equation. The student who not understand, you don't have a proper listening the concepts what I'm teaching. That's the one reason you can't understand. Let me repeat again. The first thing, we train the model, we build the model with training or testing, guys? Training, right, guys? Just 1 second. Let's open it. Okay. So when we split the data, we have training part and we have test part. Remember, bias refers to training. Variance refers to testing. Sheikh, answer it, man. Don't ask it. I'll talk to you. Can you wait? Please understand, guys. So, guys, are you getting my point? So, bias refers to training. Variance refer to testing. So, we split the data with training part and split the data with testing part, isn't it? The two part we have. So, we build the model with training or testing? When we build the model training, that means it covered all training points or not? When it is covered all the training, it is very far to the testing, guys. When it is very far, that means high variance. When it is close to the training, it is called low bias. I know in this batch, many of them already completed machine learning. The one who listen it, they understand. Now the concepts are clear, isn't it, guys? Isn't it? So here, yes. So this concept's called Sheikh. Are you able to understand, buddy? Now, okay. Sheikh Tosif, are you completed yesterday's projects, guys? Yeah. Now, guys, are you getting my point? Low bias, high variance. Please let me finish, then come back to that. We'll talk. This is very important and very, very important. Now, next one. In this code, in this graph, the testing point close to the model, training point far or not? Guys, are you get this? What exactly here? The test means variance or bias? Test means variance or bias? Variance. It is a high variance or low variance? Very good, low variance. So it's far to the bias. So low variance and high bias. Guys, are we clear? I will repeat again. Very good, Srikant. Now I hope you got it. Now let's do this. I'll write here this thing. Just go to the code. Overfitting. So always remember, bias refers to training. This is interview questions. What is meant by bias, variance, trade-off, testing, low bias, and high variance is concept called overfitting. Understand, guys? High bias, low variance is called underfitting. Low bias and low variance is called best fit model. Low bias and low variance is called, this concept is called bias variance trade-off. In interview, if you encounter with this question, bias variance trade-off, please speak these 3 sentences. Guys, are you getting my point? Now let me tell you. I'll repeat again. Just listen to this one more time. A data has split into 2 parts, training part and testing part. We build the model with the training. That means low training, low bias, correct? And high variance. This is called overfits. When we build the model with all attributes, overfitting problem happens or not? So see, I train the model with all attributes over here. So that's why what problem comes up, guys? Overfitting problem. In the same graph, if I got like this line, what happened? It's close to the testing, but far to the bias. So we have here high variance. I'm sorry. High bias, low variance. So overfitting and underfitting. So I meant to say, let me tell you, there's a 3 accuracy. If anyone understand, then you can answer me, response me. Let's see. Training accuracy, 90 percentages. Test accuracy, 40%. Training accuracy, 40%. Test accuracy, 93%. Train accuracy, 84, and test accuracy, 90. I will give 3 points now. First point, second point, third point. Can you tell me, out of the 3 points, which is overfitting, which is underfitting, which is best fit? Online team, response me now. Think and answer. Okay, let's offline team. What is first one? See, now listen to this code. I mentioned 3 use cases. I'm asking you now. Rupinder, overfitting. Sheikh, what is output? Arnav, Raghav, Kalyan, Venu. Okay. So in the first case, training accuracy 90 means high bias or low bias? Training accuracy. Training, see, 40 and 90, compare which is high, which is low out of 40, 90. 90 is high, 40 is low, right? So here, low variance, high bias, low variance, high bias, overfit or underfit? Low variance, high bias, underfit or overfit? So how many say underfit? Number 1, let me read. Venu. Venu, you say second is underfitting? Very good, Kalyan. Kalyan is right. And anyone else? From online team, only 1 student responds properly. First one, overfit. Bhupinder, underfitting, which one? Guys, online team, are we clear or any response? Listen to this. Test accuracy means what? Variance. Low variance, high bias. Low variance, high bias. Oh, underfitting or not? So this one is underfitting. Guys, are we clear? Now, what about this now? Low bias, high variance. Oops. Control G. overfit. Clear now? What about this? Low bias, low variance, because 90, 84, both in same range or not? So this is called best fit model. Whenever we build any model, if we got both accuracy correct, that means there is a best fit model. Can we do same concepts in a project? So guys, online team, offline team, are you clear this concept now? Everyone, please acknowledge me. Guys, are you guys clear? Let me repeat again. See guys, in class, every model you have to check this interview questions. How to overcome overfitting. Now the model I built today or not? I need to check whether my model is best fit model, overfit model, underfit model. Can we check? Can we check guys? How do we check? If you see this, we have a score. Okay. Now check this one. Bias equal to, what is regression? Regression is a model. Regression is a which parameter? Score. X train, Y train. Bias or variance code? Variance code. Bias or variance code, guys? Guys, online team, can you tell me? The line number 53. It is bias or variance? Bias code. Now, can I go ahead and execute now? What is bias accuracy I got? 94 or not? Just go here and the model which we build, the bias is 94 percentages. Clear? And how to get a variance code? Just go to variance 54 line. Go ahead and execute. Now check variance 98. Now can you tell me bias is 94, variance is 98? Is it a good model we build or not? Is it a good model or not? So is it a best fit model, guys? It is a best fit model. So today onwards, every projects, whatever we build in machine learning, you need to check the scoring. We have a 3 type of score: training score, testing score, model score. Model score I'll introduce in classifications. I hope the concept clear. So guys, let me repeat again. This is a very powerful technique, but yes guys, in the model, if I got bias is 94, if variance is 54, you never get R square value as 0.9. You getting my point? You always, sorry, if accuracy is high, then bias variance is low. Srikant, don't think too confused, guys. Very simple. One guy write exam. He scored 94, another guy 98. Both are in same page or not? Very simple, Srikant. One guy write exam 94, other guy 50. Lot of differences. One guy score 85 or one guy got 98. Still both are same. Both comes under distinctions or not? It is means best score, best accuracy. Okay, now any more questions here? In case of grades above 90, say both Swaras, everything is same, buddy. I'm trying to give you example because, sir, is it between 0 to 10 is best? No, Pratish, not like that. 0 to 10 means here 94 percentages, guys. 0.94 means what? 94. Here 0.98 means 98 percentages. Are you guys clear? So don't think too much. Just follow me. If you understand this concept, day to day, you more concepts clear. So yes. What is a range to define, guys? Whose question? What is the range to define under over best? Very good question. Shashi Kumar, based on the practical, I'll get back to you. You get to know. The range you can consider as if overfitting is 80, if bias is 80, variance is 85, good model. If bias is 80, variance is 95, good model. The ratio shouldn't be greater than 30. I mean to say, if your bias is 90, if your variance is 60, it's not good. And also, this is not one property you check the model is accurate or not. There's other properties as well, guys. What is other property? R squared, adjusted R squared. R squared should be greater than adjusted R squareds. There's a few properties to check the model is accurate model or not accurate model. Sagar, sir, then how low bias, low variance, guys? That is a concept, man. See, would you say high bias, high variance? No, the bias variance trade-off means when you say 94, when you say 40, you don't try to scrutinize the concepts, because let's see, if the car you ride, engine is repaired, you open and check what everything happened inside. So very simple. Understand, this is what we speak, this is what the interviews you can talk, your round will be clear. Okay, Sagar? All right. So what if I didn't teach you this concept? What if I skip these concepts? You guys getting my point? So I don't want to skip any piece of the practical, guys. So here today we complete all the projects with end to end with lot of learnings. Isn't it, guys? Just go to the, I think, copy. You can make this code as neat and clean. Okay. And finally you deploy. So guys, file and SLR practical. So guys, are you understood? Let me tell you, 94, 98, do not consider it is a high bias, high variance. Okay, do one thing. If you feel I'm wrong, then do one moment. You go to the interview, you can speak high bias, high variance. But before that, I want to introduce some of the documentations. Just refer to that and go here. Okay, bias variance. Let's refer to this graph and we try to explain whatever the concepts we learned today. Just go here. We done this one. High bias, low variance. Low bias, high variance. Okay, team. Okay, I want to show this graph now. Overfitting, underfitting, good balance, best fit. Low bias, low variance. It is a best fit model. High bias, low variance. Underfit model or not? Sagar, do you see? They don't mention here high bias, high variance. Are you clear, buddy, now? So if your accuracy is 0.1, you never say it's a low bias, low variance. Just change the thought. So here, low bias, high variance, overfitting. Concept clear? So which one we need to consider? Which one we need to consider, guys? Good balance. This is called best fit model. This is called best fit model. So here, what is bias variance? Okay. So this is all those things. So optimal balance, we always consider as good balance, guys. So this is bias, this is variance. This would be the optimal balance. I hope understand. So there's a lot of learning today. And in today's session, I'll introduce OLS, R square, adjusted R square, ANOVA analysis. All right. SSR. ANOVA means what, guys? SSR, SSC, SST. Clear? And then anything miss? Okay. Training accuracy, bias, variance, and then training score, testing score. Okay. Regression stable. How R square is greater than adjusted R square. So now the statistics which I taught you on the last week, can we connect practically or not? Can we connect practically, guys? Also, this is all the learnings. We done backend model. We done backend model. and we done front-end model. All right. And we deployment, we completed. So finally, guys, simple linear regressions, not required, Alina, all those things. See, the use cases predict the future, isn't it? To predict the future, how your model accurate. If you see, I think see guys, you people don't work much, ask more questions. It's realize that how much strength you have. Let me tell you. I can see by ask your questions itself. I think someone done gold price. Who's that? Vamshi. Do you see gold rate predictions app? Now what he done? This is called right guy. The reason why he take a data set from 2013 to 2024, right? The gold price. Now, what is the gold price now, guys? I think 60. Sales price predictions, ticket price predictions, weather forecast, house price forecast with two attributes. In tomorrow onwards, we just complete one algorithms, guys. We have multiple algorithms. You guys getting my point? Understand everybody? So what I'm trying to say, used to compare. No, it's wrong, Alina. Where did you learn? ANOVA is statistical analysis to compare mean of two or more groups. Absolutely wrong. See, just now we created this, guys. We have SSR, SST, R square, guys. So are we completed this? So now simple linear regressions we completed. Can I give you small practical? Highly partial training data, then bias. I'll respond to your answer. So can you give few examples of how the model fails? Does it? Let me tell you, we are done just one algorithms. All right, guys. So please complete. When the time comes, we get to see all those things, guys. You ask 1,000 questions, but these interview questions asked by Wipro. The questions which you ask, now the questions which asked by company. See the differences. Now you can Wipro. Bias variance trade-off, explain. Did I explain to you or not? Did I explain to you or not? Now, you will speak this or not? See, I don't mind, you can ask thousands of questions. I have an answer for everything. But if you don't see every questions, you may satisfy, you may not satisfy. So you may ask a questions, you not acknowledge the questions. It should have common sense, guys, isn't it? So now, different performance metrics. Are you able to respond to these two questions, 32, 33? Can you tell me answer for 33 now? That's the way you answer? Online team, can you answer this now? 34, 33. How do you respond? Sasikumar, the questions which you ask, interview, nobody asked that. Venu, the questions which you ask, your brain passes questions to you to ask. But the brain which you passes questions, that's the incorrect questions, and the questions does not matters at all. Guys, you understand? Very few people understand what I'm trying to say. See, my brain can say me any questions, guys. It may be relevant, it may be irrelevant. Okay, now, if you see this difference between now, different performance metrics. How many performance metrics? Two. Regressions performance metrics, classifications. In regressions, R squared, adjusted R squared. In classifications, confusion metrics. Time series, what is Arimax model? Why using RNN instead of LSTM model? Why RNN other than neural network model? How do you initialize the weight when neural network? In current project, why use neural networks rather than traditional ML model? Sir, bias trade-off is ML model with No, it's not ML model, Raman. So bias variance is the concepts to check the model training score and testing score. So we have low bias, high variance is overfitting model. High bias, low variance means underfitting model. Low bias, low variance is best fit model. So the best fit model we call as bias variance trade-off. Clear, guys? Now this question is asked by fractal. The fractal, exactly, Srikant. So why dropped a few columns? Anyone answer? Team, are you left online, guys? No. Can you please respond to this? Why dropped a few columns? Anyone answer, please? To prevent? Exactly. Who answered this? Offline team? Very good. Excellent, Sheikh. Good answer. Prevent, Hina, it's not error. Prevent overfitting. They may increase accuracy. No, it doesn't matter. It's not to prevent overfitting. Imbalanced data, how to balance it? Venu, can you respond, man? Do you know what questions you encounter in interview? You understand now? If I don't using Hina absolutely wrong, no, no, I didn't teach you this. These are big concepts. Where can you apply ML problem, giving a problem and provide solutions? Okay, you guys 10-year experience, or some of them are 15-year experience, some of them VPs, leaders are there. Now, okay, what is meant by smoothie technique? We have a mini technique. So the first interview questions I'll ask, in your project, you have 15 years, right? You come to me, I take interview, I'll ask one questions. In your projects, where you implement, I know, don't give me the full form of the Miss One. Explain that. Okay. In your project, what problem you fit it and what solutions you done, explain me. In resume, you never worked in organizations, right? Even though 15 years, you never worked in machine learning. Now they will ask you, you mentioned in a profile, boss, 4 years I worked in the project as ML engineer. Now you go, he will ask, in the project, whatever you worked, how do you finalized? What is the problem and how do you give a solution? Valid questions or not? This is the valid question. How do you respond? Okay. Okay. What issues you face during deployment? Valid questions, important questions. The experienced people are there. They understand what I'm asking now. So guys, do you want to prepare like this or not? So guys, I will explain each and every concepts. I'll explain what is VIF, explain R square. Would you explain R square? What is the formula of R square? 1 minus SSR by SST. What is SSR? What is SST? ANOVA. ANOVA divided into 3 parts. SSR, SST, SSC. Explain like this, man, he will plan on you. But explain theoretically, practically. What is covariance? What is covariance? See, I take interview now, guys, mock interview. You understand what is covariance? Online team, you left, you there. Venu, what is covariance? Just now I covered. This is the problem. We keep learning new topic. You forgot all the old topics. Srikant, correlations. Very good. Can you please change? Relation variance among two attributes is covariance. It's act like covariance. Exactly. In depth to which two variables can vary. No, man. Correlations also we call covariance. Isn't it covariance? We done. Null and residual deviance. categorical data, how it related to output findings. Very good. 50 number questions. These questions asked by HCL. See, I'm not copy and paste it from Google. What happened? Every batch, I'll take 5 months and 5.5 months, or maybe it's go to 6, maximum 5.5 months. The last day, assume I have only 30 students from offline, or maybe 10 students from offline, 30 students from total 40 students. Out of the 40, I create WhatsApp group then. It's my personal group. Not now. I find out the jewel out of it. So what is the purpose of the group? There's a many things. Why LinkedIn connections, guys? We try to connect a equal-minded people. Getting my point? So you know what is equal-minded, unequal-minded people. There's a two people things are there. So try to understand. Regressions. What is equations? Y equal to mx plus c. But see, from the data set, we have, it doesn't matter how much attribute. What is dependent variable? C, excellent. Price. What is independent variable? Let's say square fit or not. From the code, can't I select one dependent variable and one independent variable? So yes, I can build simple linear regressions model, guys. So online team, Hina, understand? Yes, guys, Raman, Arnav, Kalyan, Apurv, everyone. Yes, we can build. It's, see, they give the data set. It's depend on us. How am I choosing? For example, Pratish, I hope clear. So I want to show this practical also I build. Can you try yourself, or I'll, one moment. Regressions project. One moment. Simple linear. Okay, let's go to the practical. In this practical, I'll show you NumPy pandas matplotlib. Read the data set. Considered space as square feet living. Correct? Price as dependent, independent. Can I build now? So from the data sets, we pick only two variables. One is square feet, one is price. Now, can I build this model? Train, test, split, all this random state zero, linear regressions, predict text test, visualize train, visualize test. Do you see this, guys? Do we see we have outlier or not? That means 1, 2, 3, 4, 5, we have outliers. This is training, testing. This is, I mean, these house space is high, the price is high. The space is high and price is high. Guys, are you clear? Can I share this code? Will you work? So this is, so dear team, so we have completed simple linear regressions model. Tomorrow, I just try to give you, so there's a lot of things. We also done some mock interview today. We also understand mock interview to get prepare yourself. The moment when I complete machine learning, I give some resumes you can apply. So tomorrow we work on generative AI, Google generative AI, large language model, Google generative AI, LLM models, guys. Are we clear? So I hope you guys understand. If you not understand, it's up to you. Ask me if you have any questions. Sir, was this workshop delivered? Means in the, I don't understand previously. No, it's already done, but you can't understand that.